Sometimes we don't necessarily have a slope and a y-intercept given to us in life, and all we have to look at is a number of data points that help us maybe make some sort of prediction on what's going on in the real world. And that'll get us to something called correlation. We're only going to look at linear correlation today, and we'll try to figure out how can we make a model given some data. So I have an example here where we have the number of chapters in a book, and let's assume these chapters are all fairly uniform length, and we've got the number of typos that are found in those chapters. Okay, so we're going to look at this example, and we're going to try and write a linear model for the graph. And all that means is we're trying to write the equation of the line, so y equals blank x plus blank, and then we're going to predict the number of typos in a book with 14 chapters. So when you get a problem like this, three good steps here to check out would be, first, if your points are not already plotted, plot them first. So in this case, the points that I have on that graph are already plotted, so that's no problem there. Second, draw a line through the points that seems to model the data. Okay, and then if you don't have a graphing utility to help you out, you've got to pick 2 points that seem to model your line of best fit and find the equation of the line. Now, if you have something like Excel or a graphing calculator, those things will help you do this, so you get a nice, more exact answer. But in this case, we're just going to do this by hand today. So, all right. So what I'm going to do is I'm going to go back here and I'm going to draw a line of best fit that just kind of seems to model the data. Okay, there's good lines of best fits and bad lines of best fits. This would probably be a pretty bad line of best fit. It doesn't really seem to model the points very well. So let me see if I can do this here. Sometimes I'm not the best with this pen, but we'll go ahead and make that my line of best fit for this problem here. And now what I'm going to do is I'm going to pick 2 points that kind of seem to fit this line that I drew, and it looks like maybe these two. Again, you could pick 2 different ones. We would get slightly different answers, but in the end, our predictions should be pretty similar. So I'm going to pick these 2 ordered pairs to write my line of best fit. So I've got the point 4, 6. So 4 chapters, 6 typos. So 4, 6. And I've also got the point 7, 10. So we got 7 and 10. And what I'm going to do is I'm going to go ahead and find the slope so I can write the equation of this line. Okay, remember that this is the x-axis, so chapters deals with x, and the y-axis here would be the number of typos found, so that's how we can tell these apart. And then I'll just do 10 y2 minus y1 over x2 minus x1 to find the slope, 7 minus 4. So my slope is equal to y's being subtracted and the x's being subtracted. So that should be 4 over 3. Now if you pick 2 different points, you might have a slope that's like 1, you might have a slope of, I don't know, 5 over 3 or 5 over 4. Again, we're just going to get a ballpark example here. So not everybody would get the same answer to this question. So we got 4/3 would be our slope. So let's go ahead and plug that in. So we're going to take the 4/3 and put that right here. And now let's go find the b just like we did before. So I'm going to plug the 4 in for x and the 6 in for y. So this will be 6 is equal to 4 over 3 times 4 plus, we don't know what b is, so we're solving for that. So this would be 16 over 3, and that's going to give me about 5 1/3 here. So 4 times 4 over 3 is about 5 1/3. The reason I'm writing it this way is because this is going to help me, just kind of think where the y-intercept would be. And if I subtract, that gives me a y-intercept at about 1 1/3 for my b. Okay, that's a little more helpful for me in this case when we're looking at a real-world problem. So 1 1/3. And that would be now the equation of our line. Okay, so that takes care of part 1. So we got y equals 4 4/3 x plus 1 1/3. And now the only part we haven't done yet is predict the number of typos in a book with 14 chapters. We just found the linear model. This should be able to predict, different numbers for us. And when they give you these extending questions, they want you to use that equation that you just found, and they're usually going to give you an x value to plug in to find the y, or they'll give you a y value to plug in to find the x. Okay? We're going to have to decide which of these things we're given. And in this case, since they say 14, we want to know the number of typos. We know that number of typos is y. We want to know what that is. In a book with 14 chapters, which is x, we're going to plug the 14 in for the x to find the y. So let's free up a little space here to do that. I'll have to get rid of this slope stuff here. And now to figure this out, we're going to go ahead and plug our 14. We just said that was an x value. We're going to plug it in for x. So we got y is equal to 4 over 3. And then we got a 14 in here plus 1 1/3. And we'll go ahead real quick and punch this in. So 4 over 3 times 14 plus 1 1/3. Okay, and that's giving me approximately 20 typos. Okay, so in a book that has 14 chapters, we can predict about 20 typos in that chapter. Again, if you were to actually kind of extend this line up and up off the graph, you could eventually, see that that might be kind of a reasonable, if we doubled the distance here, we could see that that might be a reasonable prediction for the number of typos in our book. Okay, so again, you might do this problem, pick two different points, you might get 18 typos, you might get 21 typos. It just depends on the points you pick. But overall, we should get a pretty similar answer as long as we pick 2 points that seem to be in that line of best fit. If you do this on Excel, it might give you an even more accurate answer. Just make sure that if you get a decimal number of typos, that you round that to the nearest typo, because you can't have a decimal number of typos.